So we are given here to prove this identity in which they are saying minus 2 sine squared x plus cos x plus 1 all over 1 minus cos in bracket 540 degrees. There should be degrees here. Minus x is equals to 2x minus 1. So to start with here, you need to consider here as your left hand side, then here as your right hand side. So after you name your left hand side and your right hand side, you need to look at both sides. Where you are going to, because you are asked to prove that this expression is equal to this. So you check where you are going, you see what is there. Here it is cos x that is there. And on my left hand side, we all have cos x except for sine 2x. So what we need to do is when we look at where we are going, it means whatever is here should be expressed in terms of cos. So if we want to express it in terms of cos, what do we look into? We look into change sine squared x because it's the only one that does not have cos x here. So we are going to use the double angle identity, which says cos squared x plus sine squared x is equal to 1. So from here, let's leave sine squared x alone. We are going to have sine squared x is equals to 1 minus cos squared x. Meaning that when we come back to our expression here, where there is sine squared x, we can substitute with 1 minus cos squared x. Meaning that we are going to have minus 2 in bracket 1 minus cos squared x plus cos x plus 1 all over 1 minus, I will write this as it is, 1 minus cos 540 minus x. Right? So from here, we need to simplify the bracket. Here, it means we are going to have minus 2 plus 2 cos squared x plus cos x plus 1 all over. Now from here, let me just simplify here. I didn't want to simplify it now, but let me just show you something. So we have cos 540 minus x. Remember our reduction formulas in grade 11. So if you want to reduce this, because remember this angle is a big angle. If you want to reduce this, then I can subtract everything. I can subtract minus 360 here, meaning that I'm going to have cos 540 minus x minus 360, then which will give me cos of 180 minus x, which is equivalent to negative cos x. Meaning that I can replace cos 540 minus x with negative cos x. Meaning that I will have 1 plus cos x. Remember there is a minus here, plus this minus, it's going to be a positive cos x. Now from here, let me just arrange it in a proper way. I'm going to have 2 cos squared x plus cos x minus 1, because minus 2 plus 1 is minus 1, all over 1 plus cos x. Let me move on. So when I look at my numerator here, it's a trinomial, a quadratic expression in which I can solve this using factorization. So I'm going to have 2 cos squared x plus cos x minus 1 over 1 plus cos x. So what I do from here is I factorize. How do I factorize? I look for the product and sum. If you've been looking at our videos, you know how to factorize this. So the product and sum here, we are looking at minus 2 and 1. So what are the numbers that if we multiply, we get minus 2. If we add, we get 1. Obviously, those numbers are minus 1 and 2. So when we have minus 1 and 2, we come here, we say 2 cos x cos squared x, I mean, plus 2 cos x minus cos x minus 1, let me rub off here, all over 1 plus cos x. I understand everyone understands this part. If you don't understand this part, then just go back to basic factorization. You see how you factorize a trinomial. So from here, I have to group so that I factorize properly. Here, the common factor is 2 cos x. If we factor it out, we are going to have cos x plus 1. Then here, the common factor is minus 1. If we factor it out, we are going to have cos x plus 1 all over 1 plus, okay, let me just write it properly. Cos x plus 1. So this is a common bracket, meaning that this is a factor, and this also is a factor. We are going to have 2 cos x minus 1 in brackets, then again cos x plus 1 in brackets, all over 2, all over cos x plus 1. So this and this will cancel each other, and we will be left with 2 cos x minus 1, meaning that from here, the left hand side is now equal to the right hand side. So this is how you prove this kind of a identity. And if you like our solution, if you like our video, please don't forget to go and subscribe. Thank you.